Hey everyone, welcome to IT Horror Stories with Jack Smith. I am Jack Smith as always, and I am literally joined by someone across the other side of the planet in Australia. I have Neale. Good evening to you, sir.
Good evening, how are you?
I'm doing excellent now that you are here. You reached out with a story about the Melbourne Cup and mainframes, and those are two terms that we up here in the north are not really familiar with. So can you quickly go through it? What's a mainframe, and most of all, what's the Melbourne Cup? Because that's going to be really important here.
Okay, here's the quick thumbnail sketch. 1991, the mainframe was a server that ran at probably equivalent to something like 500 megahertz in raw CPU power. The power of a mainframe comes from what it offloads. It offloads all its I/O, it offloads all its network and stuff. So when you add up all the figures, it becomes much more than a simple 500 megahertz server. So it moves data like nothing else. Two operating systems, one called VM ESA, which stands for Virtual Machine, Extended Systems Architecture, and it is a hypervisor just like VMware, but it was a hypervisor that has its roots all the way back to 1967 and the early 360s of IBM. And the our actual transaction system, which is homegrown in Assembler and PL1, runs an operating system called VSE. And VM is able to have multiple VSE guests running there. Runs on a network called SNA, Systems Network Architecture, which predates TCP/IP by some number of years. It's a hierarchical, very fast, very simple protocol. The Melbourne Cup is a horse race. The place I worked for is an off-track betting organisation run by the state of New South Wales, or it was at the time. It's now been privatised. And it was a statutory authority that was chartered to have support betting throughout the state of New South Wales in offices, agencies. I think we had something like 4,000 terminals out in the state of New South Wales, and a population of that stage of around 3.5 million people. So Australians like to bet.
Yes.
And
so
in addition to that, you could also have account-based betting by phone. So Melbourne Cup Day is the biggest race day of the year. It happens on the first Tuesday of November. So it often coincides with the US elections. People don't pay attention to the US election. They pay attention to the Melbourne Cup, and literally stops the nation. The state of Victoria makes it a public holiday.
Wow.
And the rest of the state doesn't get any work done after midday. They're having parties, they're having sweeps, etc. So it turns into just one huge binge.
Yes.
So consequently, it's our biggest race day. So people who don't bet will have a bet on Melbourne Cup Day. So our offices are steaming through transactions. It's a Mark Sense terminal where you can put in up to 20 cards at a time, and they get processed within a second or two. And times that by 4,000, times that by the number of systems, etc. It's quite a lot of transactions going through. We had a problem in the 80s where we lost the system and took down the entire state of New South Wales, so it wasn't very popular. To combat that, they split the state into two, so that if you're in one suburb, you're on one system. If you're on another suburb, next door suburb, you're on another system. And so we had that type of redundancy. So this is another hard lesson we'd learned several years beforehand. On this particular Melbourne Cup Day, I sit at my desk. I was systems admin, or was what IBM calls systems programmers.
Yes.
Monitoring the performance of the VM and VSE systems. So I can see what the whole VM system's doing, I can see what the guests are doing, and I can see that as it gets closer to race time, the CPU is spiking as races start and races stop.
Yes.
And everything was normal on this day. The race itself, I think, runs at about 320, 325. I was looking at the system about 315, and all of a sudden I see the CPU figures go from the 80s and high 80s down to 5%. And I knew instantly this was not a good thing to happen 10 minutes before the race starts.
When activity stops and fans stop spinning, that's usually not a good sign indeed.
Not a good sign. So consequently, the other system was going on. I was looking at both systems and it was traveling nicely. So it was only half the state was being affected. And on a day we're turning over $90 million to $100 million, this last 10 minutes was going to be costly. The system did an automatic restart as it was designed to do, but it lost so many minutes. And when the systems came back, everybody tried to hit the system all at once. So consequently, response times went, and so nobody was happy in half the state. It turned out it was a bug that had been introduced months beforehand. We have a freeze on software updates 2 months outside Melbourne Cup, so nothing like this can happen, he says, hopefully.
Logically,
And
fingers crossed. Yes.
yeah. And it was just an inconsequential bug. Well, inconsequential, just nobody thought about it.
Yeah.
We have a bet type called the superfecta, where you choose the first 6 horses to win in the order
Yes.
in a race. And so the number of permutations is quite high. So we try to keep a track on the pool size there by getting a sample of those permutations. So you can imagine the storage requirements are high. Well, what we didn't figure was each of the tasks areas for our betting system, as I mentioned, it's homegrown, was, say, for example, 64K. That was the heap size for each task.
That was your
the
memory
heap
size, if I get it correctly, that you had to put all the data in.
This particular application that monitors this superfecta betting thing blew that heap, but we didn't have any protection. We didn't have any checking on the stack size, heap size. So while this task was active, it was all good. But as soon as somebody hit clear on the screen or escape, we're talking about 3270 screens in these days, very different beast to a VT100, but equivalent thing. You hit the escape to exit the task. Well, as soon as it exited the task, it just zapped storage left, right, and center. So the next task to use that particular area, who was already running, just fell apart because all its storage had been corrupted, all its memory had been corrupted, and that was the root cause. And very simple problem, very simple fix. But unfortunately, when it's 10 minutes before the biggest race of the year, and we're talking about hundreds of thousands of dollars per minute, they're not a popular thing to happen, particularly out in the branches, which are actually run by the organisation. That's not too bad because they're on a salary. But people who run agencies, this is their livelihood. They get a commission on the stuff, so their commission was going through the floor for those 10 minutes. We had a lot of damage control to be done. It made the news, the television news, the 6 o'clock news that night. They came out to our computer room so they could film all the lovely flashing lights and stuff, and while the general manager of the organisation explained what happened, apologised, etc. Myself and my boss were seconded to sit by a terminal and bring up some nice little graphics and point to it meaningfully while the cameras rolled. And I just put up something that looked pretty. They're just for good visuals. So consequently, yes, we made the news. Nobody was happy at half the state. The other half were writing thank you letters saying thank you for not having, we weren't on your other system there. So it's an ill wind that blows no one good. The repercussions flew on from that night, offline processing when the systems were shut down for online use, and then all the offline reporting was run. It had damage, so I was getting calls at 1 o'clock in the morning. The old pre-alphanumeric pages, just the ones that went beep and you had to call.
Yes, indeed.
Went off. So that started about 1 o'clock in the morning, and the whole problem sort of snowballed. Well, just rolled on. Various things broke because of this for the next few days. So consequently, I had worked a number of hours, a number of days pretty much straight to get things back to normal. We got things back to normal, we got a fix in, and we never had a Melbourne Cup like that again, thankfully. And to show their appreciation, the TAB team, the TAB is the name of the organisation I was working for,
yes.
and IBM thanked me and the other guy who was working on it by giving us a day out on an America's 2 yacht called Kookaburra 3, and we did the harbour on the yacht, and I worked as a grinder, and it all went well until the Kookaburra 3 was coming in and hit another boat. So that sort of summed up the previous 7 days. We had system crashes and boat crashes.
That's a
all
very
in
nice
one
combination.
time.
When I look at the documentation for the 32270, the clear button should just clear the display. So how did it manage to actually corrupt the program then? Is that
when you clear the screen, it exits the task and clears the work area. And then because that work area was larger than what the heap size was, it just cleared too much. So it zeroed out memory of other tasks that were running, And so as soon as that other task got up, as they did, it was one of those tasks, get up frequently to check things, whatever. As soon as it got up, it got this corrupted storage, and we effectively segv'd.
Buffer overrun, and then everything went with it. It took down the entire system.
We choose not to have any subscription model nor sponsoring in order to keep our stories accessible for each and everyone. To support us, please check our merchandise at shop.ithorrorstories.eu or buy us a coffee at ko-fi.com/ithorrorstories.
This is a standard heap overrun, corruption of memory, no checking of bounds, and task getting up using that crappy memory and segving.
So then the betting infrastructure, that was, you said you had thousands of terminals. That was a terminal at the cash register, I assume, not the ones that you see today where you put in your own bets, so you will have people working those.
You put it in. It's like a teller window, and you have your tickets, and you put them in a reader, the little hopper at the front of the terminal. And when it detects there's a card there, it starts its read process. And as I mentioned, there was using a IBM networking architecture called SNA, Systems Network Architecture, and as also I mentioned, it's very hierarchical. So the time when a terminal wants to connect, it sends a request up, and it gets it acknowledged, and it forms a session, and away we go. It's much more chatty than this initial part is much more chatty than a typical TCP IP connection, but once it's up, it's blindingly fast.
It goes, but you need
doesn't go
connection.
Yeah. So when the network came back after the system started, we had 4,000 terminals trying to log in at once.
At the same time,
and then as soon as they logged in, people wanted to start betting. So it just caused a bit more grief on there.
Yeah, I can imagine that's quite a spike in data coming in when every terminal at the same time is trying to connect through that a bit more chatty routine that they use.
Actually, I've got a quick anecdote. This guy rings up IBM headquarters in Armonk. At that time, it was Akers was the name of the president of IBM. So the guy rings up and says, John Akers? And he says, yeah. John Akers of IBM? Yes. John Akers of IBM in Armonk? John Akers, yes. John Akers, Armonk IBM, chairman of IBM? Yes. He goes on like this for several minutes, and finally John Akers says, what the hell are you going in? The guy says, I just want you to know what it's like to set up an SNA session. So,
keep on adding stuff to the header. To tell them that it's
it's got this typical 6-7 layers, like the OSI layer mechanism. Not simply as simple as TCP/IP. So you've got all these different levels handshaking until you finally get the applications talking to each other. So yes, that anecdote rang very true to us who used to take care of SNA networks. So its simplicity helps during the betting period, but caused all sorts of grief at restart time.
Yes, because today we would call it lots of overhead. Back then you would call it assurance that everything worked properly.
Yeah, so that was the horror story.
So you said that the bug was introduced a few months earlier. They probably didn't test for like edge cases where that could happen, or they couldn't simulate the amount of data traffic it would generate.
It could have. We had a dedicated quality assurance team who would take over the pre-release materials and run it through its paces, but somehow this particular scenario didn't happen, and it was relatively random. It's wherever you get the equivalent of what we do, a malloc return storage from.
Yes.
And it just so happened this day it returned storage that was just butted to some other important task stuff. So it was there's never a simple answer to why a problem happens. There's a chain of things that has to happen to cause major catastrophes.
Yes.
And so this thing was improperly written, that it used too much storage. It happened to use the storage of a certain task that would get up. If it just happened to write over random unused memory, it wouldn't have been a problem, or a function that wasn't critical. then. So yes, there was just this chain of things that one pin knocks over another pin, which
Yeah,
I think anybody who's looked at aircraft disasters know it's never as simple one pilot doing one simple thing. It's always a chain of stuff that conspires
indeed.
to cause a disaster.
Yeah, so it's just by pure bad luck that the memory is laid out in such a way that you could overwrite or get into critical data, and which would then take down the system. And the next time, because it's all virtualized, it just jumps around, and just very bad luck.
Yes, it was bad luck, and again, if it happened on a non-Melbourne Cup day, it would
You
have just
wouldn't.
been a sneeze instead
Yeah.
of pneumonia.
I assume the developer was known. Did he get a reprimand? Did he get a well done for your bug, or did he run away on the first aircraft out?
The programmer never got admonished or anything like that. It was just, again, one of those things where the people doing the architecture and the design just missed the fact that this task was going to be a bigger work area than all the other ones. And so, we could blame the people who wrote the our homegrown transaction system as well. That they could have done, they could have architected things. So again, it was just a chain of things that happened. Memory management and I/O are all homegrown, written in assembler with PL1 as the main construct for writing the application part of the program there. So, so you had to be pretty skilled to do the assembler stuff anyway. So,
Yes,
if they made a mistake, well, okay, you made a mistake, but
happens.
you're a pretty valuable commodity.
Yeah. So all in all, it was a very, very perfect storm that happened that day.
Yeah, a perfect storm, exactly that. And yeah, as I mentioned, anything that's a terrible disaster is always a perfect storm of things happening.
I looked on the internet and I can find exactly one news article on this. I guess let's be happy that there is not a big internet archive from the early 90s.
Oh yeah, that's exactly right. There would have been a very different story. Once the internet was present, we were pretty early into the doing internet stuff at our organisation. I think it was 2 years later we had our first IP stuff happening, and by the time I left, our new terminals were all IP based. I really loved working there. I started straight out of high school. They had a cadetship arrangement where 2 years part-time work, 2 years part-time university, and then the last 2 years full-time with a guarantee of a job. And it was excellent. Great training, very interesting. We had to do things on a shoestring budget. That's why all that stuff was homegrown. We needed the maximum performance with minimal amount of hardware. I mean, a bank running the equivalent of the network of our size would have was on the order of 5 to 6 to 10 times larger in terms of hardware requirements and stuff like that. But because we were a state government authority, lean and mean was the way to go. So I learnt a really lot of things from doing that stuff, which I still use today. I still do VSE, I still do VM, I do a lot of Linux, I do a lot of x86 stuff, of course, but I'm still in touch with the mainframe. I'm still in touch with those people from IBM and Tab. We have our
Lovely.
lunch once or twice a year. Great bunch of people, and I think they'll be very interested in hearing this podcast.
They will be very welcome, and if they want to share their side of the story, they will be very welcome.
Oh, that'll be all lies. Don't worry.
Oh no, that's fine. Like, I am not judging. One final thing, because you said it was lots of low level assembler and everything, and then you're still doing things today. How does it compare? Because having done some mainframe assembler when I was in school, we had to type it up. It went to the compiler, and it took 5-6 minutes to come back, and everything was very still batch or oriented. How did things in those management, like dev environments, evolve in the last 35 years? Because it's been a while.
We were very big users of VM, which is as I said, a hypervisor, but also has its own timeshare environment, single user operating system, a shell you can use to do stuff. So everybody had their own virtual machine. They did their development there. We had scores of test virtual machines doing that. So it was compared to other places which were batch orientated all the time, we were pretty much online. When I started, they were still doing punch cards. There was still a model cuts there. the programmers had only just gone on to terminals there, and you had to share them before everybody got one on their desk. So that was the biggest change over the first 10 years I was there, going from a handful of terminals to everybody had one with colors, graphics, and stuff like that. All the program development, all the source code management, pre-Git was our own homegrown stuff again.
Yes.
Using similar concepts of update files and being able to track back things like that. Yeah, some useful lessons that I still use in one form or the other. I'm still doing assembler. In fact, one of the projects I was involved in, we have .NET running on the mainframe, and I wrote the JIT.
Yeah.
I wrote the JIT for that architecture. So I have done JITs a number of times for both mainframe and non. And if I have to implement another ABI, I won't. I don't know if I could survive. I have dreams about calling conventions and register and stack layouts and stuff. I've done it so many times in there, but it all goes back to the training I got back in the 80s and 90s.
Like what you hear? Subscribe on Spotify, Apple Podcasts, YouTube, or wherever you get your podcasts. Every like, follow, and review helps us grow. Check out more at ithorrorstories.eu and drop us a message anytime at hello@ithorrorstories.eu. We'd love to connect.
Technology may change, but the principles do not, is what I hear a lot.
Yeah, the tooling is the biggest change. The ability to, where would we be without GDB? Where would we be without Git these days? Those type of things. You couldn't go back to the pre days, So yeah, I think that's been my biggest noticing, and of course the internet and the rise of TCP/IP over SNA.
Having used both SNA and TCP/IP, because I get mixed messages, which is the one that you prefer, either as a user and to develop for? Because I'm hearing mixed messages from
hands down TCP/IP, much simpler. Semantics concepts. I had to rewrite a VTAM application just recently. We have an SSH suite for VSE. Because VSE didn't have an SSH client, SCP client. So I wrote one, and to give it an interactive interface, I had to give it a 3270 support so people could use a terminal.
Yes.
So I had to write a VTAM application, and the complexities of VTAM applications. I got Gemini to see what it could do. Write me a VTAM application that will open what's called an ACB, which is the root data structure, and then accept logins from users, and then write output and query the terminal for colors and geometry and stuff like that. And it did a half-assed job, reasonable job, but it got the right macros, didn't get the right operands and stuff like that. So yeah, I was reliving my youth writing this program again, and it was fun, but I'm glad I'm running TCP/IP these days rather than SNA. And if you ever had to do what's called an NCP gen, the front-end processor called 3725, 3745, so the model numbers from IBM.
Yes.
And the front-end processors running a network control program.
Yep.
And they are just monoliths to code. And in the old days, it used to take about 4 hours for it to build, and you get back a build with an error, so you had another 4 hours. By the time I was left there, they were getting done in 10 minutes, and that was just because of the processor speed and stuff like that. But you don't have to do NCP gens with TCP/IP. You just, everything's commodity.
Yeah.
So I'm very thankful for that.
You touched a final thing I wanted to mention, because you said the processing speed, because you were doing this on a 500 megahertz machine, running all those terminals, all those transactions at basically real-time wire speed. And then today we have the multi-gigahertz machines all spread out wide, and you have horizontal clusters and vertical clusters and everything up and down. And still people feel it's getting slower. Is it because of the overhead, the architecture, or is it because we have a security layer now? Because we do have a security layer now because it needs to be.
Well, yeah, the latest mainframes I've been producing are about 5.6 gigahertz raw speed, multi-threaded, etc. And again, all the power is really in the offload of I/O and stuff like that.
Still is.
But it's certainly faster running those earlier type programs than today. I mean, Java, with all the when you don't have to do garbage collection, which we never had to do in our system, that's why it was running raw fast. I mean, in the early days, we took IBM's VTAM and we bypassed 3 of the layers. We modified it to skip a whole lot of crap that had to go on just to get raw processing speed.
Yes.
Again, I'm thankful we don't have to do that these days. But yeah, I don't mind taking a performance hit for security. But when you have performance hit because someone hasn't configured the garbage collection parameters, yada yada yada, and I still find the syntax of some of the OO languages just weird, horrible, and that type of thing. But I don't mind. As I program in Java. I program in .NET. I do a lot of Python these days. I don't, and it's all nicer because in the old days we couldn't just do import and use somebody else's work to do it. We had to write it all from scratch, and so I'm glad we've got past those days.
There is no Google to give you an example. Back then, you had to make it all up yourself.
Yep.
The worldwide database of just examples that you can stitch together at least to get going.
Yeah. I use tools like Gemini and that type of thing. Just
of course,
when I want something simple. Well, if it saves me 10 minutes or it saves me half an hour over a week, that it generates, and I'm not putting critical stuff there that I have to then review to make sure it hasn't hallucinated or anything like that. But just as a simple example, show me how to split the lines and strip off such and such in 2 lines.
There you go. Yeah.
Trivial stuff like that. When I just couldn't be bothered putting virtual pen to virtual paper to do it.
I feel you. Of course, it's an entire discussion of doing what's called the AI shadow IT, where basically everything is just thrown into AI LLMs and all the company data and files come in. You can talk about if you use your own internal copilot, but if you just throw it on whatever browser window you have, well, there goes your company data.
Exactly. It just reminded me of my first use of AI to do System 7, IBM assembler, mainframe assembler. And it was hysterical what it came up with. Obviously, what being trained on was so thin that it didn't have many things to infer. So the code was absolute crap. But in the last 3 years, it does a reasonable job. As I said, when I asked it to write a VTAM app, it got the right structure, it used the right macros, just didn't have the right parameters and things like that. But you can certainly see the improvement. And now IBM have their own Bob, which is heavily trained on their internal programs. It apparently spits out quite usable stuff. But I've not used Bob.
I actually have never heard from that until now because I am not in the mainframe world myself. But I can relate just a tiny bit because we did the experiment with Commodore 64 assembler when the first AIs came out is make a solid raster line or just change the background color in assembly because that's easy thing that we can do. And indeed, in the beginning, it was nowhere. It would spit out x86 instead of 6502. But these days it's catching up ridiculously fast. And let's not ask any questions where all the data comes from. That's
yes, you don't want to know the answer to that question.
No. All right, thanks, Neale, for joining us. So this was IT Horror Stories with Jack Smith on the Melbourne Cup and mainframes and how it's moved into AI. You can find us on Spotify, Apple Music, YouTube, Deezer, and wherever you find your podcast and your panic attacks. We do episodes multiple times a month. We have merchandise, shop.ithorrorstories.eu, and you can support us via Ko-fi. Our website is ithorrorstories.eu, and our social links are on links.ithorrorstories.eu. Thanks for tuning in, and we will hear each other in the next one. Thanks a lot.
The content of this podcast is intended for entertainment purposes only and is meant to humorously explore various tech-related situations. Any resemblance to actual events or real persons, living or dead, is purely coincidental. We ridicule situations, never individuals or groups. Listener discretion is advised, and we encourage everyone to approach technology with a sense of humor and an open mind.